Hi folks, we're going to do some digital electronics here, so let's go ahead and get the PowerPoint up. We're going to do 3.3.1. So let me get them up on the screen here. Here we go. So we're going to talk about synchronous counters. Okay, so we're going to define what they are. We're going to do a 3-bit and a 4-bit synchronous up counter, and then a 3 and a 4-bit synchronous down counter. There is a difference between the two. Okay, so make sure you know the difference. So first of all, what are synchronous counters? All the flip-flops are simultaneously clocked to an external clock. We had that before, but not all of them were clocked to that. Only the first one was. Synchronous counters are faster than the asynchronous counters. Synchronous counters do not suffer from the ripple effect. We had kind of that funny looking 7-segment display on there. Now this counts a lot smoother, looks a lot better. The only problem is it requires a little bit more logic than an asynchronous counter. Okay, it's a little bit better, but we've got more logic to do it. Okay, so let's take a look. Here's the theory of it. We've got a 3-bit up counter. Here's the theory. Notice that when we do this, it's a falling edge that triggers the Q0. Okay, that's coming from the clock. The falling edge of the clock triggers it. Then the falling edge of the next one will trigger Q1, or Q1 is kind of like a divide by 2. Q0, Q1, and then Q2. So as we look at this, here's 0, 0, 1. Here's 0, 1, 0. Here's 0, 1, 1. That makes the 3. Here's 1, 0, 0. 1, 0, 1. 1, 1, 0. 1, 1, 1. And then back to 0, 0, 0 again. Okay? So that's the theory behind what's going on. Here's what it looks like when you wire it up. First of all, they're JK flip-flops. Take a look at the negative edge that we have right there. Okay, so we got a clock coming in. Q0, Q1, and Q2. Can you tell which one is the 1 spot, which one is the 2 spot, which one is the 4 spot? Let me go back and look at a little bit better idea here. So here's the tracing of it, what it goes through when we do it. Okay, I like this one better. Okay, so Q2 is your 4s, Q1 is your 2s, and Q0 is your 1 spot. Okay, so your first one here is a 1. Okay, so look at all the presets are tied to the VCC. All your clears are tied to the VCC. J and K are tied to your VCC. So when your clock comes in, the only thing that comes out is your Q. Now your Q is going to go into the next one of your clock. This one that goes up here goes to Q0, that's your 1 spot. Okay, everything else is the same. Your only output coming out is 2Q, or the second Q value. So this one goes to Q1, leads onto the clock of the next one simultaneously. Okay, notice the JK are all positive on there. Presets are all positive. And then Q coming off of this one goes back to Q2. So when you actually make this, you will see it light up. It is a good idea to use probes on these. Okay, I know some of you don't like to do that. Well, maybe you should start to like to do that. Okay, a little hint there. So that's a 3-bit counter. Here's a 4-bit counter. Again, notice the clock coming into the first one. Okay, the Q comes out of the first one, loops around, comes to the second one. Okay, that Q comes out, loops around. Those two follow into the third one. Okay, that one loops around, then we've got a 3 input AND here, and that goes into your fourth one there. Okay, so that's a 4-bit up counter. So what's a down counter look like? Well, almost similar again, because we've got the falling edge on the clock, and each time it goes through, it's going to change Q0, Q1, and Q2 to be able to go through and do that.